Hi guys, in this video I'll be covering the third part of the Spring Batch processing, and this is the domain language of Batch, and most probably this will be the last video in this series. And it will be a bit longer one, so just stay tuned and stay tight. So this is the domain language of Batch. So in this image, what we are seeing is the domains and subdomains of batch processing, and each of them I'll be explaining separately in each slide. So don't worry, we'll come back to this image again after learning about all of these domains and subdomains. So the first one which I'll be telling you about is the job. So job is an entity which encapsulate the entire batch process. It is wired together with the help of some configuration file, which is called as the job configuration. Job is on the top of the hierarchy, which we'll see here. Like right now, you just need to understand that job is on the top of the hierarchy, and once we understand job instance and job execution, we'll come back to this image again. So it is a container for step instances. Right now you don't know what step instances are, but you can think of them as basically functions which needs to be called one after the other. So let's go to this slide. Each job contains multiple steps in it and orders up the steps in the order of their execution. It applies the configuration globally on all the steps like the restartability, etc. The job configuration, like whenever we write a job, we need to configure it as well. And the job configuration contains the name of the job, the definition and order of the step instances, restartability of job, etc. So here as an example, you can see this job. So here dot get defines the name of the job. Here it is the football job, and these three functions, you can see player load, game load, player summarization. These are basically steps. So you'll understand steps in the next few slides, but right now you can think of them as functions. So basically, when we start a job, what step we want to execute first? So first, if we want to execute player load, we define it in the dot start section, and after that we have dot next, and we can just go on defining which steps we want to execute after which one. Like this is the place where we order up our steps and tell our job which steps need to be executed in which order. So this is it for job. So I hope you remember this diagram where job is on the top of the hierarchy, then we have job instance, and then we have job execution. So let's understand about job instance. It refers to the concept of logical job run. So if we want to understand in simple words, we have this diagram. Okay, let me tell you here. Okay, so just think that we have a job, okay, and its name is end of day job, and what that job does is at end of each day it will get the data of that particular day, and it will populate it in a different database. That is the job of our okay, that is the job of our job. Cool. So if we want to understand what a job instance is, suppose we so today is January 1, just for instance. So we have to run the job today, correct? So what we'll do is we'll trigger the job with certain set of parameters that tell that you have to run the job for date January 1. So here this is the job instance. So now this job instance has run and it has been successful. So now let's consider that we are in tomorrow, January 2. So again we have to execute the job since the job is the end of day job and we need to execute it daily. So again we run the job with a different set of parameters of Jan 2. So here once again we have run the job, and And since it is for the date Jan 2, it is again creating a different job instance. So basically this is how you can identify two job instances. So this you can directly read. Like here we have one EOD job, the same which I had explained. And in this case of job, there is only one job logical job instance per day. There is Jan 1 run, Jan 2 run, and so on. If we yeah, there is one more condition which can come up. For example, you ran the job on Jan 1, so it creates a Jan 1 job instance. Suppose this job has failed. Now obviously you need that data. So like now you took 1 day to figure out what was the issue. So now you'll run that job again on 2nd January for the same date for Jan 1. So in that case, since the parameters which you are passing to the job are same as that of Jan 1, you'll run the same job instance. It won't create a separate job instance. You got it? So the job instance of Jan 1, if it is run on Jan 1, will remain the same as the job instance which is run on Jan 2, providing the same job identifying parameters. So here we saw that a job instance can have multiple executions. Like if it fails, obviously we need to run it again and it will have multiple executions. But only a single job instance with respect to a job with its set of parameters can be run at a given time. Basically what it's telling is you can't run like duplicate jobs at the same time. Like you can't run, suppose you are running a job right now by providing Jan 1 as the date. You can't run the job again right now providing the same date parameter. So that's what it is telling. Starting a new job instance means start from the beginning, whereas using an existing instance means starting from where we left off. Like now you might think, how will the job know where it left off or where it failed? So that I'll explain later, because we have something called metadata tables which store this data. So yeah, here that's what I was explaining. We have the job, we understand job instance. We need a little bit time to understand more about this job execution and job parameters. So let's come to job parameters. Like how do we distinguish one job instance from the other? So it holds a set, like when we come what we say about job parameters is like it holds a set of parameters which is used to start a job, something similar to passing arguments to a function. In the earlier case, we had a job instance for Jan 1 and one more for Jan 2. It is a single job, but it is differentiated based on the job parameters, because the parameters which we provided are Jan 1 and Jan 2, and only those things are different, rest all are same. So job parameters are the job parameters is the one which differentiate between two job instances. Jan 1 would have started based on the date parameter as 1 Jan, and Jan 2 run would have started with date parameter as 2 Jan. So we can define job instance in this way, that job instance is basically job plus the identifying parameters. Here identifying parameters are nothing but Jan 1 and Jan 2. So now let's go to job execution. So this we have done, job instance we have done, job parameters also done. So last what we have is the job execution. So job execution refers to the concept of single attempt to run a job. Job instance can be executed multiple times, which I have told, because if the job instance of 1 Jan fails, we might need to run the same job instance again on Jan 2. So this is called an execution. The execution may result in failure or completion, but the job instance will be considered as completed only when the execution corresponding to it has completed. For here, let's example in here we are considering end of J job. It failed on Jan 1, but when we ran the same job instance on Jan 2, it created again the job execution, and this job execution got completed this time. So since this job execution for this job instance has been completed on Jan 2, the job instance is finally successful on Jan 2, but it was not successful on Jan 1. That's what this is trying to tell you. Okay, this you can read. It might be possible that the first execution of job Jan 1 failed. If it was run again with same set of job parameters, a new job execution is created, which was done on Jan 2. So there are few job execution properties like status, start time, end time, exit status, execution context, so on, etc. These properties are persisted and can be used to check the status of execution. So this is where the metadata tables come into picture. So for example, we ran the end of day job on 1 Jan, executed it at 9 and it failed at 9:30. So the following tables will be created and the following entries will be made automatically. So in the first table, batch job instance, the instance ID will be 1 and the job name will be end of day job. That is understood. In the batch job execution parameters, we have execution ID as 1 since it is the first execution, and the type of parameter is date and the name of the parameter is schedule.date. Date value is the value which we provided, it is 1 Jan, and it shows if it is the identifying parameter or not. It is true. And when we come to the execution status, so execution ID is 1, job instance ID is 1, start time is 9 p.m. 1 Jan, and time is 9:30 1 Jan, and status is failed because the job has failed. Cool. So yeah, let's assume that the developer took entire day to figure out the issue, like what was wrong with the job, and he fixed the code. But like this happens in companies, right? We have only a particular window time where we can execute the job. So again, the next window for the execution of the job opened up at 9 p.m. on the next day, and this time she has successfully run the job instance of 1 Jan and it is successful at 9:30. So the job, when the developer ran the job on Jan 1, it failed, and at the same time on Jan 2 she ran it again and it was successful for Jan 1 data. And now since it is Jan 2, you have to run the job for Jan 2 data as well. So you ran the job instance by providing the identifying parameters for Jan 2, and that is successful and it completed at 10:30. So since 2 job instances are run, we should have one more entry in the instance table and 2 extra entries in the job execution table, which I'll show. So there is a note which you can just take a look at. So if the job instances don't access the same data in the database while reading or writing anything, then we don't need to run the job one after the other. We can run those job instances simultaneously. But if they are accessing the same data, then we should wait before running the next instance because it will lock up the database. So yeah, as I was like with our developer who ran the job, both the jobs successfully on Jan 2, let's see what all data has been stored in metadata table. So here we'll have 2 job instance ID because one is for Jan 1 and 2 is for Jan 2. And in the batch job execution parameters, 1 we have already seen, and we'll have the second and third entries. So here it will basically remain the same. Just you'll see that the date value here provided is 1 January and the job execution ID is 2. So basically these 2 entries are for the job instance 1 and the third one is for 2nd January and this is for job instance 2. If we see the batch job execution table, so here 1 we have already seen because it failed on Jan 1. So let's come to the second job execution. So here start time is 2nd Jan 9 p.m. end time is 2nd Jan 9:30 and it is completed. And this is the third execution ID and the job instance ID will be 2 for it because it is for 2nd Jan, and Yeah, the start time is 9:31 second Jan and end time is 10:29 second Jan, and it is completed. So I hope you understand the relationship between the job instance, job execution, and the job. So now let's go to step. A step is a domain object which encapsulates an independent sequential phase of batch job. Each batch job may have multiple steps to facilitate the batch processing. So it is totally dependent on the developer, like how complex each step might be. So we had seen in that code snippet that we had the player game, load game, player summarize, something something. So these all are the steps, and it totally depends on you, like how complex you configure these steps to be. These steps may be as simple as just loading the data from database, or it might have some major business complex queries and processing, etc. So it totally depends on you, like what you want to do in a step. You just code it out. Yeah, code it out. Similar to job, each job has a step execution. So you have understood till here. So let's continue the journey from step to step execution. Step execution represents a single attempt to execute a step. A new step execution is created each time a step is run. If the step fails to execute because of the failing of step prior to it, no execution is persisted for it. What it tells is we have step 1, step 2, step 3. So step 1 has completed successfully, step 2 failed. So in this case, the execution will not be persisted because step 2 has failed and step 3 can't be continued. Each step execution contains the execution context, which contains the data needed by the developer to be persisted across batch runs. So like we had example of 3 steps, right? So now each steps requires a particular set of date range. So how will we pass this date range between each of the steps, right? Like each step required the same set of dates. So how do we pass this? So this we can do by making use of execution context, which will be persisted across the table. Like we have seen the metadata table, so it will be persisted across that. So one example for execution context data which we might need is state info needed to restart. Some step execution properties are status, start time, end time, exit status, execution context, etc. So let's understand what execution context is. It represents a collection of key value pairs that are persisted and controlled by the framework in order to allow developers a place to store persistent data that is scoped to a step execution object or a job execution object. So let's consider an example. You are reading a file, and while reading a file, you want to store data like how many lines are read in the step in the execution context, so that when the step starts again, or the step starts for the next set of data, you can directly get the count, like how much lines have been read, and you can start from the next line. So in this case, what you do is you'll get the key of lines read count. So basically, lines read count is the key which you are providing in the meta table, that these many lines are being read. So you'll get this data from the file, and then you'll put it in the execution context. So whenever you're restarting the step, or maybe you're running the step for a different chunk of data, you'll now know like what lines of data you don't want to process because they are already processed. So this is execution context. So yeah, this table will explain you that. So here what we are saying is end of day job has one step, load data, and suppose we run the job on 1 Jan for the job instance with identifying parameters as 1 Jan, and the load data step fails. Then this is something that the metadata tables would look like. So you already know this table, and even this, and job execution as well. So now let's come to batch step execution. Here step execution ID is 1, job execution ID is 1, step name is load data. So we have started it at 9 o'clock and it ends at 9:30 and it shows as failed. So in the step execution context table which we come, here the step execution ID will be 1, and short context is the key which we have given in our code to store the number of total lines read, and this tells how many lines we have read, or basically like it tells how many lines we have read successfully, and it tells that the step has failed at line number 40322. So in this case, the step failed after processing 40322 lines, and it will allow the step to start again from the same line where it left off. This is because now we can access this data in the step execution context. Exactly one execution context must be there per step execution. So to be more precise, there should be at least one execution context per job execution per step execution. So if you want to see a code snippet like how we make of the execution context, it is this way. We check if the execution context has a key named lines read count, and if it is there, it will get the line count using this particular key, and the value will be stored in line count. Then it will initialize a line reader, and it will start reading the data in the file after that particular line, and thus it will continue. So now we are done with job and step. So let's come to job repository. It provides the CRUD operations for job launcher, job, step implementations, etc. When a job is first launched, job execution is obtained from the repository, and during the process of job execution and step execution, other data is also persisted in it, which can be used by the developer. So when a job is first launched, we have the job execution table. So these all tables which are there, it comes in job repository. So basically it provides a space for developer to store all this data and to get this data or perform operations. Basically, if you want to store this short context, number of lines read, etc., you can perform the CRUD operations using the job repositories. @enable batch processing will give you a job repository automatically configured, so you can use this anytime you want to. You need to use this actually because it is helpful. So basically you need to remember this annotation @enable batch processing. Let's come to JobLauncher. So JobLauncher is a simple interface for launching a job with a set of job parameters. So how do you trigger the job? So you can do it in two ways. One is you can create an API to trigger it. Otherwise you can schedule it daily or monthly, however you want it. So JobLauncher is the first place where the code will enter, or basically you have to trigger the job launcher to run the job. So it consists of the job and the job parameters, and these all are the exceptions which gets added automatically. So now we have come to the subdomain part, ItemReader. So you want to read large amounts of data from a database and you want to read them in chunks. So that's where ItemReader comes into picture, and it is an abstract class which represents the retrieval of input for a step. When ItemReader has exhausted the retrieval of data, it returns null. So you have read all the items in the database. So how will the ItemReader tell that it has read all? So then it just returns null to tell that everything has been read. You also have many types of item readers like JDBC paging item reader, or etc. So you can just read more about it to understand which one is the best in your use case. Like how we write data, we similarly need to write data as well. It may it be in the database or file or some other output format. So there we make use of ItemWriter. So it is an abstract class representing the output of a step, one batch or a chunk at a time. It has no knowledge of the previous or the next input which it takes. It knows only the item which was passed in the current invocation. Like ItemWriter will write only those data which has been provided to it as a input. It doesn't know like what was the previous set of input which was provided to it or what will be the next set of input. It basically just like processes the chunks of data, and I mean whatever the input or the chunk of data it gets as input, it will just write that. So now we know about ItemReader and ItemWriter. So basically, ItemProcessor comes into picture when we have to transform the data between reader and writer. So it is obvious that in most cases we don't simply read the data and write the same data. We need to transform that particular data, convert it, and maybe perform some complex queries or business logic on them. So this is where the item processor comes into picture. If the data processed is not valid, it returns null, which means that the item writer won't include it while producing the output. So this was it for the Spring Batch series. So thank you for watching it, and if you liked it, don't forget to like, share and subscribe. So thank you. Bye bye.